What if I told you that one of the world's most iconic architectural marvels was once on the verge of collapse? A project so ambitious that it required groundbreaking engineering solutions just to stay standing? Marina Bay Sands is more than just a luxury resort. It's an engineering masterpiece. With its 3 massive towers supporting the world's longest cantilevered sky park, this structure defies gravity in ways never attempted before. But few people know the extreme challenges faced during its construction. From unstable ground conditions to the looming threat of structural failure, engineers encountered obstacles that could have turned this billion-dollar dream into a disaster. But how did they overcome these challenges? And what was the revolutionary solution that saved the sky park from a catastrophic collapse? Make sure to watch this video until the end to understand the incredible feats of engineering that made Marina Bay Sands possible. Singapore is known for pushing architectural boundaries, and Marina Bay Sands was envisioned to be the crown jewel of its skyline. The $8 billion mega-project included 3 colossal towers, each standing 55 stories, 206 meters high. But what made it truly groundbreaking was the sky park, a 340-meter-long platform that stretches across all 3 towers, housing an infinity pool, lush gardens, an observation deck, and restaurants. The idea was breathtaking, but turning this vision into reality was an engineering nightmare. The first major challenge? The construction site itself. Located along Singapore's Marina Bay, the ground was composed of soft marine clay, a notoriously unstable material that posed a serious risk to the structure's foundation. If not properly reinforced, the towers could sink, tilt, or even collapse over time. To prevent this, engineers had to reinforce the ground before construction could even begin. They installed 5,000 deep foundation piles, some reaching 60 meters below ground, to anchor the structure to bedrock. But this was only the beginning. Since the soft soil could still shift, engineers built a 1.5-meter thick diaphragm wall around the perimeter, extending 50 meters underground. This wall acted as a protective barrier, keeping the foundation stable and preventing water from seeping in. This process alone took over a year, leaving just 2 years to complete the entire project. With an incredibly tight deadline, the pressure was on. With construction finally underway, over 16,500 workers were brought in to work around the clock. To keep them fed and energized, the project included the largest temporary canteen in the world, serving over 5,000 meals per day, costing an astonishing $82,500 daily just on food. But despite the workforce's relentless efforts, a major problem emerged. The towers weren't just any ordinary buildings. They featured a complex curved design, meaning that every piece had to be precisely aligned to prevent structural instability. As construction neared completion, a terrifying realization threatened to derail the entire project. The sky park, which was meant to house a massive 150-meter-long infinity pool, was designed as a cantilevered structure. However, there was a critical flaw. The sky park wasn't rigidly connected to the towers. This meant that during high winds or earthquakes, each tower could sway up to 200 millimeters independently. This movement posed a serious risk. If the towers swayed too much, the sky park could crack, causing massive structural failure or even a catastrophic collapse. Engineers conducted a wind tunnel test to determine how much movement the towers would experience under extreme weather conditions. The results were shocking. The sky park was far more unstable than anticipated, and without a solution, the entire project was at risk of failure. Watch the video until the end to find out the genius engineering solution that saved Marina Bay Sands. Instead of abandoning the design, engineers devised a revolutionary approach inspired by bridge engineering. They introduced flexible movement joints within the sky park structure, allowing it to absorb and adapt to the tower's independent movements. But that wasn't enough. To prevent structural stress, the infinity pool was divided into 3 separate sections with small expansion gaps between them. These gaps allowed the pool to move slightly without cracking under pressure, ensuring that it remained stable even during strong winds or seismic activity. This innovation not only saved the project but also set a new benchmark in high-rise construction. With the sky park's design finally secured, the next challenge was installing it atop the 3 towers. a process that required unparalleled precision. Since no crane was powerful enough to lift the entire 1,400-ton structure in one go, engineers divided it into 14 massive sections, each carefully lifted and placed into position. However, nature had other plans. Strong storms repeatedly halted operations, and when sections were mid-air, they would sway dangerously due to the wind. The risk of these segments crashing into the towers was a constant threat. To overcome this, engineers closely monitored weather conditions, lifting each section only when conditions were stable. Over the course of several months, all 14 sections were successfully secured, marking the completion of one of the most ambitious engineering challenges of the century. Originally planned to open in 2009, Marina Bay Sands faced delays due to the extreme complexities of the SkyPark installation. However, in 2010, the resort officially opened, cementing its status as one of the most recognizable landmarks in the world. Since then, Marina Bay Sands has become an architectural icon, attracting millions of visitors every year. Yet, few people realize the immense challenges engineers had to overcome to bring this dream to life. From its unstable foundation to the massive swaying SkyPark, this project tested the limits of modern engineering and proved that with innovation and determination, anything is possible. The story of Marina Bay Sands is one of ambition, risk, and groundbreaking solutions. What do you think was the most impressive part of this engineering feat? Let us know in the comments below. And if you enjoyed this video, make sure to like, subscribe, and hit the bell icon so you never miss our deep dives into the world's most incredible mega projects.